Expression packed with square roots, and yet it hides something incredibly amazing. We are given this big expression filled with square roots, and our goal is to simplify this into a much cleaner form. You can pause the video and take a moment to think about it, and when you're ready, you can always come back to verify your answer. All right, let us solve it together. But before we begin, let's rewrite the square root of 9 as the square root of 3 times the square root of 3. Similarly, the square root of 15 can be rewrite as the square root of 3 times the square root of 5, right? Now look at the denominator. Here we have the square root of 12. This can be rewritten as the square root of 4 times the square root of 3, which is simply 2 times the square root of 3. And the square root of 1 is, of course, just 1. Now let's look at the numerator more closely. We have square root of 3 plus square root of 5, and then that entire chunk multiplied by square root of 3. So we can take square root of 3 common from this group, and we are left with square root of 3 times the square root of 3 plus square root of 5. Now taking the square root of 3 plus square root of 5 common, the numerator becomes 1 plus square root of 3 times the square root of 3 plus square root of 5. In the denominator, we can rearrange the terms 2 times the square root of 3 as 1 plus square root of 3 plus another square root of 3 plus square root of 5. Let's call this entire fraction x. Now here comes the cool part. If this expression is x, then its reciprocal, 1 divided by x, will be the inverse of this messy-looking fraction, correct? Now let's try to simplify this. First, we will split the fraction into 2 separate parts. The first part as 1 plus square root of 3 divided by this full denominator, and the second part as square root of 3 plus square root of 5 divided by this full denominator. Now let's simplify each part. For the first one, canceling 1 plus square root of 3 from both numerator and denominator, this simplifies down to 1 over square root of 3 plus square root of 5. And in the second part, canceling square root of 3 plus square root of 5 from both numerator and denominator, this simplifies to 1 over 1 plus square root of 3. Now we rationalize both of these parts. To rationalize 1 over square root of 3 plus square root of 5, we multiply both the top and bottom by square root of 3 minus square root of 5. Using the identity for difference of squares, that is a squared minus b squared is equal to a plus b times a minus b, the denominator becomes 3 minus 5, which is minus 2. So we get first part as square root of 3 minus square root of 5 divided by minus 2. Now for the second part, to rationalize 1 over 1 plus square root of 3, we multiply both the top and bottom by 1 minus square root of 3. Again, using the difference of squares, the denominator becomes 1 minus 3, which is minus 2, and expression become 1 minus square root of 3 divided by minus 2. Since they have the same denominator, we can combine the numerators. So adding the numerators, we get square root of 3 minus square root of 5 plus 1 minus square root of 3 divided by minus 2. Notice something? Square root of 3 cancels out, and we are left with minus square root of 5 plus 1 divided by minus 2, or square root of 5 minus 1 divided by 2. That is the value of 1 divided by x. Now let's flip this to get x itself. So x equals 2 over square root of 5 minus 1. Let us rationalize this one last time. So multiply both top and bottom by square root of 5 plus 1. Now using the identity for difference of squares, the denominator becomes 5 minus 1, which is 4, and 2 divided by 4 gives us 1 over 2. So the expression becomes 1 plus square root of 5 over 2. And that's our answer. Isn't that incredible? This entire complicated expression full of square roots simplifies beautifully to something you may recognize as the golden ratio. If you enjoyed this explanation and learned something new, don't forget to hit that like button, share this with your friends, and make sure to subscribe for more brain-teasing math puzzles. Thanks for watching, and I will see you in the next video.